Titik tu kan.
Only TS can have negative.
Tukar dia
If that is the minimum, you have to do all three
dia
positive, no negative, right?
Ni
So
tukar T6.
this is what you do. Make sure if you have done this, everything is positive, then you only move
Tu tekan ni D.
this and this one is your extra spectrum. And this spectrum
Tu
and the spectrum, same. This was
safe. Tu nama lain.
So compare that. But before you compare it, I told you you need to get the energy. But this round the energy is not straightforward. Last report you get the energy from here, alright?
Ya, okey.
You get from here.
Kita tunggu dah.
This energy is only this energy is the energy of this and of. Okay? But that energy is not correct. Not say not correct, it's deviated a little bit. Why? Because this energy, these calculations of the contingent equations has no considerations of 0-point fraction. So what is called 0-point fraction? Back to old days, everyone thought that if you put things in zero Kelvin, okay, the things will be frozen, right? So you know if you go to the liquid nitrogen, touch it, then you die away, because you're frozen. So they thought that everything is frozen, then the structure will not move anything, right? But in reality, it's wrong. Why? Because if your atom is frozen, it's not moving, this form is vibrating. It is still vibrating. Yes, they are not moving, but your electrons fill up this form, not a spring fill up this form. So these things still vibrate. So that is called 0-point corrections. Need to correct back that this energy can be done still in this thing. Okay? So which means that these things will get the energy. Let's say this is your let's say this one is your E calculations, this one. Now you see your vibrational spectrum, not vibration, your vibrational ES. You learn it right. You always see this thing, right? Remember that? If they indicate that this one is your zero vibrational mode, their one indicate this one is vibrational mode 0. This one is the correct one for the vibrational mode 0. But you see we have an energy here. Yes, we do have an energy here. But that is not the real case because your things will vibrate at the 0 point. So which means your energy will be shifted up a bit more positive a little bit. Understand? That one is the real. Because if calculations do not include the 0-point vibration, which is a 0-point. Okay? So after you got this energy, we need to do one more step to correct the energy with 0 point. So one thing you can do is you open the log file. You open the log file by using the text pad. Then you search 0. Then you will come to here, 0-point correction, 0.147412. So now you've got this energy, right? It plus 0.147412. This one is the correct energy. And use it for relative enthalpy calculations. Last time you did not do it, now you do it. Okay? By right now, last time the lab report should also correct this one. But it's too much already inside the lab. So teach you this in the lab. Okay? Next time you do the calculations by using Gaussians or OCA or CQK or whatever quantum chemistry calculations, we need to do the corrections for whatever kind of calculations, as long as the energy is there. Okay? So you got the 5, so you need to open the files, each of the 5, search for the 0, capture this into your Excel,
No calibration.
So if you have the potential energy surface like this, and you have something like this one you know how to get right. If you don't do the corrections, which means this one will be very low. So if you do the corrections, it will be something like this. Right? So you see, the barrier is actually from here. That's correct. If you do the correction, which means your energy barrier will be something smaller than the without correction. If you don't have the corrections, then you compare the experiment, then you make the wrong conclusions. Understand? You need to do the corrections, especially if you have two potential energy surfaces. So let's say your product A, you react in this direction, give a B product, and then you will reactions to give a C product. Let's say. And then your potential energy surface should be somewhere around here. You get this one. This one will go for the C, this one will go for the B product. And you calculate it already. Now you see, if you don't do the corrections, let's say, if you don't do the correction, B will do. Now if you do the corrections, maybe after corrections, we don't know what is the magnitude of the corrections. Let's say if you do the corrections, the energy will be here, but you get these things, the energy will be here, the correction. Which means that C is more favorable if you do the corrections. Now you see, if you don't do corrections, then your things, when you do more than one calculation stuff, let's say one potential energy surface, two reactions, then you will miss the decision. The judgment will be wrong as well. Understand? So you need to do the corrections when you do the quantum energy calculations. Okay, so any more questions? So now the thing is just repeat the rest, then you should able to get the five energy, five spectrums, and then do conclusions, which one is the low energy one, and which one is the best example of the infrared spectrum in the experiment. Right? Then go back to lactic acid. You sample all the possible structure for the lactic acid, and then run the calculation again, see which one is low energy, and calculate all the infrared spectrum, and then compare with the experimental spectrum, see which one is the closest example, and reduce the structure. Any questions? So that report should be 2 parts for this one. So you don't need to snap many things to me, just 2 pages, right? You want to show me the how efforts you put in. You give 1,000 effort, you cannot get the answer, it's useless. Understand? Work smart, not work hard. Understand? You go to industry later on, your manager prefer which one? You know the answer already, right? So now you train you here. Okay? So in the lab one, what you need is, I won't tell you again, what you need is, do I give you any example? Did I put into the okay, this one? I think I have one. which one is the best one? Which one is the good one? That same in the experiment. And same thing again, repeat for second lesson. Okay? So any questions?
Yes.
How will you very easy? How will you just now already?
Ini
Okay.
kita kali tadi bersih. Sini
So
ada
this one, let's say this one.
history tak dia dapat sudah poinnya. Tu tidak kuat.
Now everything is real, right? Plus net negative, the first one will come out. Okay? So now how many vibrational mode here? 42, right? So how many atoms here? I don't know. 16 atoms. 48. Minus 6. 42. 42, correct?
Bisa. Lah pukul lain. Mood.
Three and minus 6. What is n? Number atom. Just now here, what is that? 30.
Ini mood bukan
16. 16 times 3. 48. Minus 6. 42. 42 of vibrational mode. This I tell you, now what you learn is correct one. Very stupid. I mean, I did teach you that what you learn is correct one. That's stupid. Okay, first question. Or spectrum version. So, spectrum is you cannot. You cannot, you cannot.
Eh.
If you cannot use your hand, so anyone practice?
Ini cakap mana kita kena mandi? Ini cakap mana kita kena mandi? Harmonik dua. Oh, loh. Keluar. Point tu dia harmoni muat tak semua. Mana? Nanti kalau Apple iPhone.
So once you have the spectrum like this, right, then you can do something for the spectrum as well. If you prefer to look at it in the inward way, then you can do here, you can do inward axis. Okay? Of
Tak
course,
ada.
if this one is the absorptions, then you want to have transmitted to inward or right axis. Okay? Up to you. Okay? So now, this spectrum, if you want to save it, which
Screenshot.
purpose you want to save? Save it as a picture, and you just screen cap it. If you want to save it as a data format, so that you can plot in other software, let's say Excel, possible, you can right click and save the data. Then you want to save it, this file, you contain X, Y column. So plus X is your wave number, Y is the intensity, right? And then you can plot it out. Okay? So one more thing I need to point out into the spectrum is one. I think you should have something to do with the scaling factor. Alright? I don't know where that comes from. Yeah, the scaling factor. We're going to teach you. So what is scaling factor? Like just now what I told you, your infrared spectrum is based on vibrational spectrum, which is harmonic. Right? And we know that harmonic is not perfect to describe your chemical system because your harmonics, your calculate your two atoms vibrations, it will be like this. But we know that in real, that this atom compare the experiment. Your experiment you measure is real thing, no approximation, as long as it's infrared active. So you use vibrational frequency, harmonic frequency to get the infrared. And your harmonic frequency on something is not right. So all
Kalau
your
ini mati kan?
frequency here you need to times the scaling factor
Sekali mati hidup.
to counteract on the enharmonic effect. Then only can compare with infrared spectrum. So if you want to include the enharmonic effect, what you need to do, what you can do is, before you save the file, then you can go to the properties. Which is this one, right? Then you select this one, scale one. Then you do the scaling factor that I asked you to do, 0.982. Okay? Then your whole spectrum will be moved to the left. Okay? You need to get this. When you show the
Kenapa
spectrum
3.98 ni?
your left pole.
Kenapa kau sampai 9?
Now, see this one? Let's say this one. This is 3169. It is calculated using harmonic approximation is 3227. The highlighted is highlighted as well. Okay? So let's say I change it here. So it's not 40. So 42 is 3257 harmonic approximation calculated. Including the enharmonic effect of the scaling factor, it will be 3.99. What we want to compare is 3.99 with your experiment. Understand? So that's why the program will allow you to do the scaling. Because you know that this software uses harmonic approximations, it will be not appropriate to compare with the experiment, which is the real vibrational form, which is not harmonic. Okay, any questions?
Betul. Why 0.982? Apa? Skip by 0.982. Kita kena guna kan ada kata scaling kat gini. Sebab dia bagi betul. Ni lah. Faktor dengan 0.98 ni. Tukar dia akan jadi shifted.